Specialised masonry restoration were called to an old warehouse in Texas. It was constructed in the early 1900s. It was 3 stories high and approximately 20,000 square feet. The building was built with multi-width brick walls, 3 layers wide, bonded together with an English garden bond every 6 courses. The mortar used to bond the bricks together was lime-based, as Portland cement was not introduced until the early 1900s and was not readily available. A close inspection of the exterior of the building was carried out on all elevations, and deficiencies of the brickwork were noted and documented. The brickwork on the front of the building was good quality engineering bricks, high in slate content. They are resilient to moisture, unlike lesser grade bricks on the other elevations of the building. The erosion of the mortar joints were severely more than the other brickwork. There were 2 visible fall pipes made of mild galvanized steel and built into the brickwork. A cement coating at the top of the parapet that was protecting the brickwork from weathering had spoiled severely, and pieces had been falling off the building regularly over the years, a concern for pedestrians entering and leaving the building. The mortar in between the corbelled brickwork was eroded enough to make the brickwork dangerous. This is a picture of the building next door with similar problems to the brickwork. The fall pipes are located in the same place as the other building. Cracks were seen in the parapet areas, and the mortar was also severely eroded. Steel coping had been installed on the top of the parapet to protect it from the elements. The right-hand elevation had 3 balconies installed. They were anchored to the masonry. The masonry had been cut out and new windows had been installed, but without lintels to support the masonry when the balconies were installed. Note how the balcony was installed crooked. The masonry above the installed sliding door had collapsed. A closer view of the masonry. Note, there is no steel lintel in place. The brickwork had collapsed without notice and crushed the furniture below. Luckily, the balcony was not being used at the time. The original window had been replaced with a larger window/door. The original header was left in place. The brickwork above had been repointed somewhat because cracks had appeared with the brickwork bowing. The balcony came in a kit form, and here you can see that they did not install even the brackets straight during the installation process. A view of a window that was installed without a balcony. The masonry above the window was not supported. A closer view shows the masonry dropping, and the left of the picture, the original steel lintel was still in place. The water had got behind the cement render and, due to freeze and thaw cycle, caused it to crack and fall off. The lintel has corroded and has bowed downward and caused cracks above the brickwork. When repointing masonry with diamond grinding tools, dust is always a major problem. This is why SMR uses high-powered dust extraction units to remove the dust at the tool. SMR has a patented, applied for pointing machine. Years of research and development produced a machine that is engineered and computer operated to remove the old mortar. BrickPoint can give a uniformed removal of mortar joints to any specified depth that is specified by a structural engineer or architect. With the old mortar removed and the walls washed down with water to remove any debris, repointing with new lime-based mortar got underway. In this picture, half of the masonry has been repointed. Masonry supported and awaiting steel lintels to be installed. SMR pointed around the electric for safety purposes. Any electrical wiring must be inspected by a certified licensed electrician. Here, a view of the finished repointed wall. This was achieved using the BrickPoint machine. The rear of the building, which was the main entryway to the building, also had masonry problems. Access to the masonry was restricted due to a storage building that had been added in years gone by. Bricks had been cut out to gain entry to the building. The brickwork was supported by an ill-fitting steel lintel. The masonry had been replaced and was in disrepair due to poor workmanship. The brickwork had been cut out at the second floor, and the window was installed with no lintel supporting the brickwork. The top section of the building had lateral restraint anchors installed horizontally to stop the masonry rotating outward. This is done by installing a horizontal bar through the building and attaching steel plates and a nut and a washer. The steel bars are installed through the wall near the roof. A view of the turnbuckle used to apply the tension. Here, at the other end, you can see where the steel rod has been attached with a bad weld to the turnbuckle. In the middle, the bars had been poorly tack welded together. When working from a boom lift, you must always be aware of your surroundings and obstacles such as entryways and electricity poles, and most of all, pedestrians. When working on any building and creating access to work is always a problem that has to be overcome. The main entrance was on the south side of the building. The top section of masonry was suffering from spalled brickwork and the parapet cement coping was falling off. The windows on the second and third floor are original. The window on the ground floor was installed in the 1980s and constructed of glass blocks. With the old mortar ground out using the brick point machine, new mortar was applied. SMR used 2 boom lifts. One team were the grinding team and the other team was the repointing team. With hot summer days, SMR incorporated a cooling system in the boom lift to keep the workers nice and cool. The parapet wall coping was in disrepair. SMR repaired the damaged areas around the top of the building. When the cement render was applied, we repainted them in white. Coping stones were set by high winds from a tornado that had passed close by to the area. The final view is of the finished elevation, repointed and repainted.